Got tangent ratio? Yeah, sine, cosine, tangent, those trig ratios. And that's where I'm starting with vocabulary. What's a trigonometric ratio? Yeah, it is. That's why we abbreviate it or say trig a lot instead of trigonometric or trigonometric. A trigonometric ratio is a ratio, which you'll recall is just a comparison. A comparison of two numbers. Those two numbers are the lengths of two sides of a right triangle. Tangent compares the leg opposite and the leg adjacent. When we get to sine and cosine tomorrow, we'll involve the hypotenuse. But a trigonometric ratio is a ratio or comparison of the lengths of two sides of a right triangle. So our first goal is to be able to call them correctly. Which one's the hypotenuse? It is the longest side. Sometimes you can't tell which is the longest, and I wouldn't just count on that, but is there another way to describe across from the right angle? Okay, so my right angle's over here. I'm going to go across from it. So clarifying, this is the hypotenuse. That hasn't changed. That's still the hypotenuse. So the other two are legs. Now, in part of what you did yesterday, the legs were the same length. In another part of yesterday, you called one short leg, long leg. Today, we're going to call them opposite leg, adjacent leg. Opposite means across from. Adjacent means right next to. So we have to figure out, depends which angle. Depends which angle. If I am using this as my angle, I'm not going to be using the right angle as the angle when I do the trig ratio. It's going to be one of those two acute angles. So from that angle, which leg is this vertical one? That's opposite because it's across from the angle. It's across the triangle. So this is the opposite leg, or leg opposite. Spell it the right way. And then this would be the leg that is adjacent. Adjacent or right next to or hooked on to the angle that I'm focusing on right now. If I change my focus, if I say, okay, I don't want angle A, I want angle B. Is this still the hypotenuse? Yes, it's still across from the right angle. Okay. Is this still the opposite leg? Now, in relation to angle B, now this one is adjacent. And this one is opposite. So opposite and adjacent will change terms depending upon which angle you're focusing on. Now, just for instance, if I would try the right angle, which leg would this be in relation to the right angle? Adjacent. Which leg would this be? Adjacent. Where's the opposite leg? The hypotenuse isn't even a leg. So there wouldn't be any. So as far as sine, cosine, and tangent, for our purposes, we're not going to use the right angle. In trigonometry class, they will talk about how you handle things like right angles and obtuse angles and so on in trig. But for what we're doing, a right triangle is all we'll focus on. All right, so what is, I guess let's define, what's a hypotenuse? Leg opposite or leg adjacent? I'm in the habit of saying opposite leg instead of leg opposite. Here's your notes. Continue. Okay. Hypotenuse is the side opposite of the right angle. Leg opposite is the leg across from the selected acute angle. Leg adjacent is the leg attached to the selected acute angle. Let's mark, let's say this bottom one is my selected angle. Write the words on each side. Which one's hypotenuse, which one's adjacent leg, and which one's opposite. In reference to that bottom angle. What's this one called? This be hypotenuse, opposite leg, or adjacent leg? Related to that angle. Opposite leg. Good. Which is this one, Sam? Hypotenuse. Okay. Right leg. Another one. Adjacent leg. Okay, questions about that vocabulary? Finish with the notes. Ready? Okay. All right, so the tangent ratio that we're doing today is the ratio that compares the opposite leg to the adjacent leg for an acute angle and a right triangle. The ratio that compares the opposite leg to the adjacent leg for an acute. And I'm trying to think how they ask you these at the beginning of your sentence. I guess mostly they have numbers on them. Okay. What's a Pythagorean triple? What three numbers make a right triangle? I think we talked about Pythagorean triple when we did Pythagorean theorem. What three numbers work in that equation to make a right triangle? 3, 4, 5. Know any others besides that? Doubles 3, 4, 5. 6, 8, 10. This one doesn't look like one of those. This looks more like a 5, 12, 13. That's another Pythagorean triple. Okay, I'm going to mark this as T. And I want you to write down what fraction is the tangent of angle T. Or just simply tangent of T. What's the fraction? What over what? Each of you figure it out. Yes, it does. Because it is the opposite leg on the top, the adjacent leg on the bottom. So whatever the opposite leg length is, and then the adjacent. I want the two numbers. And this probably would be good to put on the marker board so I can see who's got it and who doesn't. What over what? Show me. From angle T, I want the opposite leg on the top, adjacent leg on the bottom. Would be the fraction of let's see. Okay, which leg is opposite of angle T? Which leg's across the triangle? Across the triangle. 5. And which leg is adjacent to angle T? So it should have been 5. All right, and without changing a whole bunch of numbers, let's use the same picture, but let's do the tangent of angle R, and I'll make this angle R. So on the same picture, what's the tangent of angle R? The leg that is opposite of angle R, the leg that's across from that, 12. The leg that is adjacent to it is the 5. So it should be 12 over 5. Now I want you to give me the fraction and then grab your calculator and divide the numbers, get a decimal to 4 places. All right, this one I'm going to use a 7, 24, if it's 25 or 26. I can't remember. I think it's 5. Okay, let's go with this one, and I'll call it A. I want you to give me the tangent of angle A in a fraction, and then decimal also, 4 places. So which side over which side? Which leg is opposite of angle A? Which one's adjacent to angle A? And then put it in decimal. If anyone does not bring their own calculator, you're probably going to definitely want it from this point on, doing our tangents and sines and that. Fraction is what over what? 7 over 25. 24, sorry, yes, I'm sorry. 7 over 24. Okay, the leg that is opposite of this angle is the 7. The leg that is adjacent to this angle is the 24. So your fraction should have been 7 over 24. In decimal, that was 0.2917. Would round with a 7 on the end. Okay, give me a thumbs up or down if you got that. Okay. Do I need to do more examples of those? Not too much. All right, I'm trying to see if I can cut out something a little bit. All right, let's grab your calculator. And if you don't have a calculator, well, I actually want everyone to look at this table. Let's go to page 705. And then if you don't have a calculator with sine, cosine, tangent, come grab one. But on page 705 is a table of trigonometric ratios. Okay, so on this table, they have like the cosine, or we'll stick with tangent today. The tangent of the degrees, like of a 1 degree angle, a 2 degree angle, those decimals that we were just dividing. There's a standard decimal depending upon what the angle is. So I want you to look up a couple things for me. Let's have you look up the tangent of a 15-degree angle. So we're on page 705. So look for 15 degrees. And then go across to tangent. And what decimal do you get? Is it 0.2679? Anybody having trouble finding that? Okay, how about tangent of 68 degrees? Find it? 2.4751. Okay, so that, you see how to read the table? Now you noticed I was using a calculator. Let's use your calculator. Can you get those two numbers from your calculator? Now, it has to be in degree mode, but we can probably tell that if you're getting the right answer or not. Now for the calculator I put in the angle first, then hit tangent. But a lot of you use the one where it prints in the screen. So you would need to activate tangent. So hit the tangent button and then 15. So yours is like mine. So yeah, you're going to put in the 15 first and then hit tangent. Okay, yours you're going to put the angle in first. So put in 15 and then press tangent. 0.6279 is what it's going to be. Places. Try tangent of 68. 24751. Anybody having trouble? Okay, I have had students take a test or quiz and they're not in degrees, so they weren't looking at the table at all, and so these numbers, your calculator can do what are called gradients and radians. Those are different kinds of measurements for angles, and if you're in that mode, 30 degrees is not the same as 30 radians, and so all those numbers were off. So it wasn't a good test score. So I had that person redo it. All right, and I'm going to show you real quick how to find a missing leg. Okay, so here's a problem I want you to write down. Let's try and find this leg. This one we know is 12, and this looks like about a 25-degree angle. Yep, this one in your notes for an example. We're going to try and find the missing leg. Could we do Pythagorean theorem? Why not? There's no hypotenuse. And even if we had the hypotenuse, I guess, depending what we're missing two sides really. So yeah, there's just not enough side measurements. Can't do Pythagorean theorem. But we can do the tangent. So we can do the tangent of 25 degrees. What would be the fraction for the tangent of 25 degrees for this triangle? Opposite leg is x, adjacent leg is 12. So tangent of 25 equals x over 12. Okay, have that written down with this picture. Why is it x over 12? X is the opposite leg, 12 is the adjacent. Okay, now we can just solve this problem, or this equation that you just have, and come up with the missing side. What you need to do to solve it, this tangent of 25 degrees, put that all over 1. And now it's going to be like the last chapter we were working on where you cross multiply. Okay, so we need to take 12 times the tangent of 25 degrees, and that's going to equal 1 times x, which is just x. So to get x, you need to take 12 times the tangent of 25. 12 times tangent of 25 equals, and depending on the directions, I'm going to go two places. 5.60 it would round to be. See how I solved it? That's how we can find leg if we don't have enough to do the Pythagorean theorem. Question on how I got this set up. Okay, let's do one more and then give you a little bit of time to do some homework. Okay, find the height of a tree. Well, the tree's probably going up. We'll call that the height. We could measure this angle, looks like a bigger angle, 65 degrees. We could measure how far we are from the tree, 10 feet. Based on those, we should be able to figure out the height of the tree using tangent. Tangent of 65 h over 10. And what did I do? Over 1. Cross multiply. So you can't just take 10 times 65. No, it's the tangent of 65 you have to take times 10. So the tangent of 65 multiplied by 10 will give you the height. Tangent, yeah, let's go tenths this time. 21.4 approximately. And there's 10th. Okay, so read the directions. That didn't do something I wanted to show you, but question on this one? Okay. Let me just mention an example before I have you work. Because I didn't do one where it's like this. Let's say this is a 28 degree. Notice if I set this one up, tangent of 28, what over what? 6 over x. This time the variable's in the bottom. And I want to show you what it looks like when you cross multiply. Okay, because notice it doesn't say take 6 times the tangent of 28. When you cross multiply, that is x times the tangent of 28 equals 6 times 1. 6 times 1 is just 6. Well, is it added? Right, this is multiplied here, so to get rid of the tangent of 28, we have to divide. Divide by the tangent of 28. And that'll cancel out. So this time to get x, you have to take 6 divided by the tangent of 28, not multiplied by the tangent of 28. So 6 divided by the tangent of 28 equals, let's go, 11.28. So how do you know to multiply or divide? Set this up and cross multiply. That might be the part we have to talk about a little bit more tomorrow. But the beginning part where you're just putting the sides over each other. And, all right, so I'll give you the whole assignment. We'll see what parts we need to clear up tomorrow. And tangent is not on tomorrow's quiz. Just the beginning part with the radicals. So page 560. The beginning part of this is just what we were doing at the beginning, writing which side over which side. You might have more questions when you come to the triangles that you're solving, but as much as you can. yesterday?